Welcome to my presentation about designing animated maps with the reader in mind. From the paper of Cognitive Limits of Animated Maps written by Mark Hauer. As the technology grows to become more robust, animation is becoming to find its place in cartography. But the important thing is that the problem is no longer the hardware or the technology issues. It's the map user that have limitation grasping all these data presented to them, and they have trouble remembering what they saw and integrating it into their knowledge. In order to better understand the issues related to viewing animated maps, we first have to understand the human brain. This is the human brain. Humans have two main types of memory: long-term memory and working memory. Long-term memory, with its unlimited capacity, stores knowledge and skills in the form of mental models and knowledge schemas, which act as a basis for future understandings. In contrast, working memory is the part we use when we process information. This section needs space for processing data and is constantly in interaction with the long-term memory to process data. This section of the brain is limited, and in fact it can only store around 7 limited chunks of information. Now we go back to our animated maps. We know now that we need to consider the limitations of working memory. This is known as cognitive load theory. Now, why is this important for cartography? Let's consider a map that you have never seen before. When we see a map, we use our working memory, and with the help of schemas, the information is transferred to long-term memory. Therefore, the content of the map is actively constructed by what we bring to the map and does not necessarily exist in the map. And that means the meaning is derived by linking signs to reference. And we should remember that we have to always try to reduce the cognitive load. When reading a map, there are three types of cognitive loads involved. The first one is intrinsic cognitive load. Based on this, the more complex a map is, the more fundamental information it contains. The second one is extraneous cognitive load. In this one, needless information is transmitted when design is not good and if there are too many distractions. The third and the last one is the gamma cognitive load. This results from learners' active engagement with the material. The relevant information is kept in the learner's brain when putting active effort into learning. Now you might ask, are there ways to manage cognitive loads in map animations? The answer is yes. There are two different ways that cartographers use to get the most output of animations. And then the first one is using intervals, the augmentation of using events, which includes controlling the presentation speed and nonlinear individual navigations. And the second mean is structuring the animation, and by that we have the potential to decrease distracting information and to divide the map into chapters to be more effective than showing all information in one part. There's still 3 other important issues related to animation that we need to consider. The essential animated related topics are user control, split attention, and modality effect. In user control, by controlling the map, the user is an active learner and not a sheer passive reader. Interactivity is good for focusing on details, and for an overview it is recommended to use non-interactive maps. And we should always remember, too much interactivity could also be destructive. Balance is essential. The second one is split attention. Split attention is a problem when more than one source of information are shown. When things have a connection, they must be placed near each other and also appear at the same time. A good solution for the time when too many information are shown is to combine text and spoken information. This way, the brain is capable to understand both information, and the danger of overloading information decreases. The last one is modality effect. The capability of understanding information through the eye and the ear simultaneously is a basic human skill. When using more than one sense, the limited amount of the working memory is increased. And at last, it's also essential not to include unnecessary information within the dual mode information transition. Thank you and bye.